All right, we're going to use the unit circle to find cos and sine of some different angles. So first we're going to do cos of 3 pi over 4. So always remember the x coordinates are all cos thetas, the y coordinates are sine theta. So to find the cosine of 3 pi over 4, what we need to do is find 3 pi over 4, which is right over here, and it's the x coordinate. So this negative root 2 over 2 is the cos of 3 pi over 4. So that's the beauty of the unit circle. All the answers are there. If I want to find the sine of 15 pi over 6 though, always make sure the angles are in lowest terms. So both can be divided by 3. So this is the same as the sine of 5 pi over 2. So here I need to find 5 pi over 2. So 3 pi over 2 is the y-axis pointing down, and I'm just going to count by quarters. So that's 3 pi over 2. The x-axis, positive, is 4 pi over 2. So then the y-axis pointing up is 5 pi over 2. So the sine of 5 pi over 2 is 1 because it's really just the y value at 5 pi over 2. And now we're going to find tan of 4 pi over 3. So the tan of anything is always a little trickier. And the reason is that tan is y over x. What you have to remember is all the denominators are 2 in general. So when I find 4 pi over 3, the y value is negative root 3 over 2. The x value is negative a half. The 2's always cancel. So the negatives also cancel, so I just get root 3 over 1, which equals root 3. But for absolutely any point, as long as the 2's are the same, it's really just the numerator of the y value divided by the numerator of the x value. And last but not least, tan of 5 pi over 2. So we already know 5 pi over 2 is that positive y-axis, so it's that point up at the top, 0, 1. The y value is 1, the x value is 0. There's no denominators to worry about, so this is just 1 divided by 0, which does not exist. So that's our answer. The tan of 5 pi over 2 is undefined or does not exist.